Alright, we're going to be looking at another inverse test for trig functions. So this one's very similar to one on the test, but not quite the same, so you do have to apply your own thinking. And this is what it's looking like. Alright, so we've got f of x, we've got g of x. If they're inverses, then two things have to be true. Say it with me. F of g of x equals x, and g of f of x equals x. I know there was no way for you to say that with me because I didn't tell what you were saying, but you can play it back. Right. F of g of x equals x, and g of f of x equals x. This isn't something that we make true. It's something that we test to see if it's true. And if they're both true, then the functions are inverses. Okay. So here we go. F of g of x is, well, let's just start by writing out f of x, but with a big blank instead of the x. Yeah. And then what goes in that big blank? Well, it was x, but now it's g of x. So 3 inverse cosine of x. Okay, hopefully you can see within the, by the way, here's a new word, these brackets, this is everything getting plugged into the cosine function. We call that the argument of cosine. I don't know why. But 3 and 3 are both within the argument of cosine, so we can treat everything within there as though it's in brackets. Cosines. And that means that you can prioritize your cancellations there. So those 3's can cancel out. And that means you're left with cosine of inverse cosine of x. Ooh la la. And then you're applying, so x would be a ratio. You put it into the inverse cosine function, you get out an angle. And then you immediately put that angle back into the cosine function, so you get back the original angle. In other words, cosine and inverse cosine are inverse functions. So they cancel each other out and you're left with x. That's the prettiest x ever. Let's do the other side. All right, this time we're writing out the g function, my g, but then we're putting a big old blank, and that's where the f function will go, right? Because originally the g function was 3 inverse cosine of x, but we've replaced x with f of x. There's f of x. Cosine of x over 3. Okay? So obviously we haven't substituted a value of x into the argument of cosine here. So we can't do any cancellations. The next thing to look at for simplifying would be cosine and inverse cosine, because they're applied one right after the other. And again, they're inverse functions, so whatever the argument of the internal function was, that's going to be the output when we put it through the inverse function as well. So we've got 3, there's x over 3. Cosine and inverse cosine cancel each other out. 3 times x over 3. What cancels this time? That's right, you're left with x. In each case, which means these are inverses. And we haven't mentioned this before, but another way you could say that is just g equals f inverse and f equals g inverse. Isn't that nice?